Okay, we are on freezing point. I skipped the last slide, so if you've printed this off, you'll kind of notice that. Freezing point, it's the opposite, obviously, of boiling point. It's at 0 degrees Celsius or 32 degrees Fahrenheit. The reason that it's brought up is because, whenever water freezes, it creates this really cool crystallization. And in fact, every snowflake is a different shape. It's so cool. If you've ever seen snowflakes sort of zoomed in, it's because of those hydrogen bonds. They can just create all kinds of different cool shapes. But really what this is talking about is like salts and ice. When it gets icy outside, people will put salt down. And the reason that it does that, it's not because it melts it necessarily. It's because it creates that freezing point to become lower. And so because the temperature is not as low as it needs to be, that ice will melt then. So it's kind of cool as far as that's concerned. And this, some properties of acids, I would never have you memorize anything like this, guys. These are just different types of acids. And, a few of them you might know. Some of them you probably don't. Like acetic acid is vinegar. Carbonic acid is in carbonated drinks. Hydrochloric acid is in your stomach. And also used in different things like stain removers and things. Lactic acid is in milk, and so on and so on. But these are just some properties of acids. They taste sour. They change litmus paper from, they turn it red. And this is one of the labs that I would have had you guys do if we were still in class. And it reacts with metals, and it also neutralizes bases, meaning that if there was something that was basic, like highly basic is just as bad as highly acidic. And if you had something that was really basic, you could neutralize it with some acid. Here are some bases. They have these fancy names, but we know them as different things, like sodium hydroxide, like lye or soaps. Potassium hydroxide is in drain cleaners. Ammonia, we've heard of that before, household cleaners. Magnesium hydroxide, this is like milk of magnesia. So whenever you have like acid reflux or anything like that, that's something you could take. And anyway, some properties of bases. They have bitter tastes. They change litmus paper to blue. They're really slippery, like soapy feeling, and they neutralize acids. Okay, I am not really going to get into this. So, as far as all of this is concerned, I do want you to know that an acid is a proton donor and a base is a proton acceptor. And neutralization is by mixing acids and bases. And I can kind of explain this a little bit in the fact that this is hydrochloric acid, and it takes this and it donates that proton over there. So that's why it's saying that it's a proton donor, whereas a base is a proton acceptor, because this ammonia here, it takes that hydrogen, it accepts that proton, and then it becomes, it becomes more positive that way. So, all right, there's strong and weak acids, and bases for that matter. And this is just telling you some of the strong acids versus some of the weak acids. Strong acids are obviously ones that are going to like burn your skin if you touch them, They're very dangerous. There are some acids like lemon juice and orange juice. Obviously, those things are very acidic, but they're not going to hurt you if you touch them. So there's different levels, okay? And this is just showing you some different acidic items. And okay, the pH scale. So this kind of shows you different substances that you know. And basically here on 7, this is pure water. So anything that goes this direction, that is all acidic stuff. And it gives you all kinds of things that you should know. And then, the further up you go then is basic things. So pH is the power of 10 notation, and it is it's showing you here on this table, which you can't see very well, that like for instance, here's 10 to the 0, and then 10 to the 1 has a pH of 1, and then 10 to the 2 has a pH of 2. Okay, so it is in power of 10s is how they come up with that scale. And then here's some properties of different salts. And they give you all these different types of salts. And we have done salts whenever we did ionic bonds in chapter 9. These are just some terms that we might know them as. These are their common names. These are their formula names. And these are just sort of things that they're used for. So you guys can read through some of that if you're kind of interested in some of these. I don't really need to read this to you. But, salts are, obviously we use them for different types of things. We use them for cooking and things like that, but also for, all kinds of chemical substances use salts for all different reasons. So you can just go through some of those uses. And then last, I think, is hard and soft water. Hard water has a lot of calcium and magnesium in it, and it's really hard. It's got lots of buildup in it, and some things have really hard water and some don't. I have a well, and I have extremely hard water, so my I have to use a softener actually, and that kind of breaks down some of those metals like the calcium, magnesium. Otherwise, there's a lot of buildup in my pipes, on my hair. It kills my hair. Really good tasting water though. So, it 6 one way, half a dozen another. Okay, I do want to show you this other thing really quick. I want to show you this example. This is in your book. This is example 11.1. And this is the only math-ish thing on here. Okay, so this is saying vinegar that's prepared for table use is a mixture of acetic acid and water that's usually 5% by weight. Oh, I forgot. I can't write on the book part of it. And it says how many grams of pure acetic acid are in 25 grams of vinegar. So kind of remember those terms like solute, solvent. So this is saying how many grams of pure acetic acid are in 25 grams of vinegar. So what do you think is the solvent in this case? That would be the actual, that's like, or the whole thing, the whole solution is like the vinegar, right? And so this is saying how much solute, how many grams of pure acetic acid. So if you go through, you know that you've got 5% by weight, and this is the math portion that I was saying is you have to figure these percentages. And so this is one of the equations, this M solute. I tried to click on it. I don't want to copy it. There we go. M solute divided by M solution times 100% is equal to the percent solute. So if you solve for this M solute up at the top left here, then you have to do a little bit of algebra. So you got to take this one on the bottom. I really wish I could write on this, obviously. This M solution, you got to multiply it to the other side. So you have M solution times percent solute divided by your 100% solution. And if you take that 25 grams times 5 divided by 100, you get 1.25 grams of solute. Okay, so if you did the same thing for this 11.2 here, let me see if I can bring up this notes thing. Kind of scroll up here. Okay, this is saying that a solution used to clean contact lens contains 0.002% of volume of thimerosal. I don't know what that is. How many liters of this preservative are needed to make 100,000 liters of cleaning solution? Okay, so this is wanting us to figure out basically the same thing as we just did, only in liters instead of in mass. Okay, we did 1.25 grams of solute. Now we got to figure out how much liters of solute. Okay, so you can do the same exact equation. So if you are going to try to figure out how much solute, okay, you can do the same thing where you take this and you multiply it over to the other side. So you've got, let's see, 0.002% times this 100,000 liters of solution. Okay, that's this. This is the percent. This is the solution. Divided by 100%. That's this number right here. Okay, so that I'm trying to get this all by itself. So if you take 0.002 times 100,000 divided by 100, you get 2. And your percentages cancel, and you're left with liters. So that's your answer there. Okay, so that is it for chapter 11, and I am gonna add a little bit of homework onto Connect and also